launch. We have liftoff of Falcon 9.
Payload deployed, Commander.
December 21st, 2015 at 8:06 p.m. Eastern Standard Time or 1:06 p.m. Universal Coordinated Time. You are looking at the Falcon 9 on the SpaceX launch pad as it awaits its 8:29 p.m. local launch. Welcome to the live webcast of the SpaceX launch of the ORBCOMM mission from Launch Complex 40 out of Cape Canaveral, Florida. My name is Lauren Lyons. I'm a mission integrator here at SpaceX, and I'm standing outside of mission control at our company headquarters here in Hawthorne, California. As you can see, we have tons of people out here really excited because today is not just any old launch for SpaceX. Today's launch represents a series of firsts for us. It's our first flight following our approximately 6-month hiatus following our June 28th anomaly. It's the first flight of our upgraded Falcon 9 rocket. We're going to tell you more about that later on. We'll also be deploying 11, yes, 11 of the ORBCOMM satellites, another first for SpaceX. And today, if all goes well, we'll make history by being the first to fly back and land the first stage of our rocket to land. Tons of stuff going on today, so let's get started.
On your screen, you currently see the inky blackness of the beautiful night skies of Cape Canaveral, Florida, where we're about to launch 11 ORBCOMM satellites aboard our Falcon 9 rocket, standing tall and proud. I'm Michael Hammersley, a materials engineer here at SpaceX, and I'll tell you a little bit more about what's going on. The 11 ORBCOMM satellites are sitting inside the nose of the vehicle. We call that the fairing. It's a shell comprising carbon fiber and aluminum honeycomb. It is sitting on the main body of the rocket, which actually comprises 2 stages. The first stage is what gets the entire rocket up to about 100 kilometers in altitude. At that point, the second stage separates and continues taking the 11 ORBCOMM satellites up to low Earth orbit, which is moving at about 8 kilometers per second, or 8 times the speed of a rifle bullet. The first stage will actually continue its trajectory and reach an apogee that's a maximum height of about 200 kilometers before, and we're very excited about this, before coming back to land at Landing Zone 1 on Cape Canaveral ground. Next to the rocket, you see the transporter erector, also called the strongback. It's actually what moves the rocket from the hangar to the pad, raises it up, and then supports it until liftoff. It also serves as a conduit for fuel and electrical connections to the vehicle. Surrounding the rocket, there are several lightning protection towers called catenary towers. These direct the energy from a lightning strike safely into the ground. Florida is the lightning capital of the United States. The Space Shuttle launch site was struck by lightning about 3 times a year on average. You'll also notice a location of white smoke. That's totally normal. The propellant that we're using is liquid oxygen, which is so cold that when it becomes a gas, we need to vent it in order to prevent the rocket from overpressurizing. And even as a gas, it still, again, is so cold that it will cause, there we go, that's the plumes. It will vent and condense the atmosphere around it, just like when you're breathing out on a cold morning, you can see your breath. To the upper right of your screen, you see a countdown clock, and follow us below on the mission progress bar to see where we are during launch.
Good evening. I'm John Innsbrucker, the Falcon 9 Product Director. I've been following the countdown the past few hours, and I'll be bringing you status updates as we go through the webcast. Now, as you saw, people are gathering in front of the mission control room here at SpaceX headquarters in Hawthorne, California, and we'll bring you more of that energy as we go during our webcast. Now, currently, as I've said before, launch is the most exciting part of the job for the team here at SpaceX. We'll hopefully see the payoff for a lot of hard work in just a short while. Now, if you've been with us on previous webcasts, you know there are 4 factors that we look at in determining readiness to launch. The first is the Falcon 9. The good news is the SpaceX team is working on no issues at the moment. Now, unlike previous Falcon 9 missions, liquid oxygen propellant loading began just a few minutes ago at T-minus 35 minutes. Now, in the past, we began loading inside of T-minus 3 hours. But Falcon 9 now uses liquid oxygen at colder temperatures, provides a denser propellant. That allows us to put more propellant on the vehicle. But it also means that we need to load that propellant as close to launch as we can to keep it from warming up. Now, because we can put more on the vehicle, that means we have better performance. That results in heavier payloads to orbit as well as the ability to land the first stage, something that hopefully we'll see in just a little while. The second factor is a satellite. Today, Falcon 9 is carrying the 11 ORBCOMM second generation satellites. The ORBCOMM team is go. Their next event is going to internal power. Third, the range is ready to support with tracking and flight safety equipment. Their people are in place. The hazard areas are clear. And finally, the weather. Everybody likes to talk about it, but nobody can actually do anything about it. We've got a 20% probability of violating conditions. Mostly we're watching ground winds right now, but we're currently go. So at T-minus 17 minutes, 15 seconds, all systems are go.
Hey, I'm John Federspiel, a lead mechanical design engineer here at SpaceX. And as you heard, we have a lot of really awesome stuff coming up on today's webcast. Now, most importantly, we're launching 11 of ORBCOMM's second generation satellites into low Earth orbit. And today's launch is actually going to complete ORBCOMM's constellation around the Earth, allowing them to provide better global coverage for all their customers. Now, if you're not quite sure what I mean by low Earth orbit or constellations, don't worry, because we're going to get into all that orbital lingo a little bit later on in today's webcast. We're also going to talk a bit about the many upgrades we made to our Falcon 9 launch vehicle, which includes a 33% increase in the overall vehicle's performance, as well as a bunch of other items to improve the overall vehicle's safety and reliability. Now, as most of you know, on June 28th, we did suffer a mishap with our CRS-7 mission. An investigation team was formed, and they determined the most probable cause to be a faulty strut within our second stage. Now, our engineering team didn't just address that faulty strut, but they looked at other vulnerabilities across the Falcon 9 and applied those lessons learned to today's launch vehicle, making us much more reliable, and we are all super excited to get off the ground. The third thing we have to talk about, and hopefully get a chance to show you, is the landing of our first stage. Now, if this works, it'll be a huge first for SpaceX, and the first for a rocket that delivers a payload to orbit. Now, this first stage will actually be coming back and landing at a former launch pad from the 50s and 60s, which we have renamed and called Landing Zone 1. And in the past, we may have made attempts at bringing that stage back at the drone ship in the ocean, but this time around, we're bringing it back at Landing Zone 1. That's what you see on your screen right there. And the overall area is substantially larger that we actually can bring that stage back. And we plan, as we've said already, to show you as much of this entire return process live on air today. And if that's not enough excitement, we have Tim Urban. He's the writer of the website Wait.Why. I know I'm a huge fan. He's here to join us and talk about space and space flight in general. In fact, one of my friends, Tom Perderio, actually was able to give him a tour, so let's check that out now.
I'm Tim Urban from Wait.Why, and we're here in the SpaceX headquarters in Hawthorne, California. A very exciting place to be. And I'm here with Tom Perderio, and we're going to go look at some things.
Yeah, let's go take a tour.
All right.
All right, Tim. So welcome to SpaceX.
Yeah, this is very exciting.
Yeah, this is the main factory floor as we're walking right out to it right now. First thing is the Mission Control Center, which is right there. Whenever you see shots of people like, on the monitors in front, kind of like old school
Right.
NASA style like mission monitoring, that all happens right there. That's the #1 spot where mission control happens.
Yeah.
So this thing right here is the first Dragon spacecraft. This is actually the first commercial spacecraft to ever orbit the Earth and successfully re-enter. Before this spacecraft, the only people who had ever done it were the United States, China, and the Soviet Union or Russia.
Right, this is like what everyone had to take SpaceX seriously
Exactly,
for this.
yes, correct. And we have our Merlin manufacturing facility right here. The centerpiece is the Octaweb assembly area.
Yeah.
This is actually, what you're looking right here is the bottom end of the rocket right there.
Right.
And so as Merlin 1D engines are created in the assembly line down here, they're wheeled over and then they stick them right into the Octaweb, all 9 of them right there. And again, the Octaweb is the solid core bottom of the rocket.
Yeah.
It's called the Octaweb because it has 8 slots for engines with a 9th in the middle right there. That's a lot of force right there inside one small package.
Oh yeah, no, it's incredible. Altogether, that could list 360 cars.
Yes, yeah, that's a lot
up in the air.
That's a lot of stuff. So this part right here is my favorite part of the entire factory floor. This is the Dragon clean room. This is where we assemble the
And those
Dragon
are all the
spacecraft.
clean men.
These are all the clean men
Yeah.
here, wearing the bunny suits to make sure that none of their hair or dust gets into the actual Dragon spacecraft.
Right.
All these guys are completing this Dragon, and they're eventually going to take all the red remove before flight stuff off, clean it up, and get it ready to roll out to Cape Canaveral. So in tank land, there's actually like 3 or 4 first stages stacked up behind there, and
Awesome.
getting painted and having all the electronics and plumbing put inside them. Last but not least over here is our 3D printing facility. So a lot of the parts are so
Look at
small that
this.
it's actually very difficult to make them with traditional manufacturing processes.
So is it that it's cheaper and easier to make it 3D, or is it that this 3D is the only way to make this the way they want?
It'd be very difficult to make some of these structures. Like, how would you mill this structure, right? It'd be very difficult to do.
Right, you can't like do it in a mold or anything.
Yeah,
really,
exactly.
that
So,
usually.
but if you 3D print it, you can print anything.
Okay, this is awesome. Thank you.
Anytime.
I can't believe this is your office.
It sometimes shocks me too.
The Falcon 9 is currently on the pad with 11 nearly identical ORBCOMM satellites inside of its fairing. But why? Well, this comes down to two main things: the purpose of these satellites and the orbit that we'll be taking them to. So first, a bit about the purpose. Customers all over the world are looking to ORBCOMM to provide communication services, such as remote monitoring of farming equipment on the ground, tracking delivery of trucks from point A to point B, and even monitoring the temperature of the goods in the backs of those trucks to make sure they get to the place that they need to be in good condition. But in order to do this, ORBCOMM must provide them with continuous coverage, or a constant signal from the satellites to the receivers on the ground, and do it globally. And this is where their orbit comes into play. Falcon 9 is going to launch these 11 satellites to low Earth orbit, which in this case is about 620 kilometers high, which is approximately the distance from LA to San Francisco. So while that may be close, it's certainly not easy. Satellites in low Earth orbit have to move really, really fast in order to keep up with the curvature of the Earth as they're orbiting, to avoid deorbiting and crashing into the planet. In fact, they're going so fast that they make one orbit in only 90 minutes. So for a single satellite in low Earth orbit going at about 8 kilometers per second, as it zips past its receiver on the ground, it loses its signal. Hence the 11 satellites, which are forming what is called a constellation. With a constellation, as one of those little satellites zips past, there's another one right behind it to pick up that signal to provide that continuous coverage. And with these satellites being strategically placed around the globe, they can provide global coverage to their customers. These 11 satellites that we're launching today are going to join the 31 others that are already in ORBCOMM's constellation on orbit, which includes 6 that Falcon 9 launched back in 2014. So we've been with ORBCOMM for a while. They've been a great customer and a great partner, and we thank them for this launch today. So now that we know our rocket or our mission objectives for today, let's learn about the rocket. We told you about this upgraded Falcon 9. Process Improvement Engineer Kate Tice is going to tell you more about what we've done.
Hey, Kate.
Hey, Tim.
Nice to meet you, and thanks for taking time to tell me things. I have a lot of questions.
No problem.
I've been told there's upgrades to the Falcon 9.
Yeah.
Which is cool, because it was already a really rad rocket.
So thinking from top to bottom of the rocket, we've extended the second stage as well as the interstage. We now have densified propellant, liquid oxygen. We also have a 33% increase to our performance.
It's taller, it's a longer rocket.
Right.
Why?
We have extended the size of the second stage because we've decided to add more propellant to that engine. So we have extended the length of it as well as extended the skirt of the engine itself.
Okay, right, so it's the skirt.
Yeah.
I've learned things. So the skirt is what I've been calling the bell.
Yeah.
All right, so the Falcon 9 is the Falcon 9 because there's 9 of these.
Yeah.
But then there's this secret 10th engine
Yeah.
because the second stage has one big engine.
Yes.
Why is it bigger than the others?
Whenever we are ascending through the atmosphere as we launch from planet Earth, we have to escape the pull of gravity. So we need lots of engines tied together to help us do that. Once the second stage and first stage separate, first stage will come back down and re-land. Second stage will continue on. At this point, it's already in the vacuum of space, so the engine has to be a little bit different to operate in that new environment.
Now, you said something about liquid oxygen, and I want to mention something about that because I thought that it was some fancy thing I didn't understand. And all liquid oxygen is really cold oxygen. So cold
Air you breathe.
that it's liquid.
Yeah.
And you need to take it with you because there's no oxygen in space, and
Yeah.
making it liquid allows you to take 1,000 times the oxygen per volume. It's 1,000 times denser.
Yeah.
But then you said in the upgraded Falcon 9, the oxygen is colder. So what does that
Right.
mean and why?
We had chilled liquid oxygen before, also known as LOX. Now it's super chilled. So it's a lot colder than it was before, allowing the molecules to pack together tighter, and therefore allowing us to take more of those oxygen molecules with us into space.
So still liquid,
Yeah.
but closer to the freezing point then.
Yes.
This is so interesting and so exciting. Thank you.
We're at T-minus 8 minutes and 23 seconds and counting. We're still go here at SpaceX headquarters for an on-time launch. Earlier, we had a go-no-go readiness poll at T-minus 38 minutes. That's where the SpaceX launch conductor verified the team was ready to enter the launch auto sequence and load propellants. We're now inside of 10 minutes. we're opening the pre-valves and beginning to chill in the Merlin engines in preparation for the ignition sequence right before 0 seconds. Liquid oxygen is continuing to load on the second stage. We'll finish liquid oxygen loading somewhere between T-minus 3 minutes and T-minus 2 minutes. Now we load propellant from the ground storage tank through umbilicals. The first stage gets loaded through an umbilical that plugs into the base of the first stage. You can't see that on the views that we're showing you on the camera. The second stage is connected with an umbilical that comes from the erector over to the base of the second stage. In a few minutes, we'll see the erector recline away from the Falcon 9. You may get a view of those umbilicals. We've got liquid oxygen, helium, fuel, and electronics all going to the base of the second stage. Currently on the spacecraft side, the ORBCOMM spacecraft have transferred to internal power. Nothing left to do between now and launch. The range continues to be go. Weather continues to be go also. We've gotten the final balloon data at upper altitudes. We're go for the upper altitude winds. So at T-minus 6 minutes 50 seconds and counting, all is go.
Hi, my name is Trip Harris. I'm the manager of Falcon Recovery here at SpaceX. So right now we're standing on the landing pad. It's made of 282 feet in diameter worth of reinforced concrete. It's all designed to handle the loads of the rocket coming down and landing on it. One of Elon's stated goals is to bring down the cost of access to space. This is not only reducing the cost of access to space, but enabling the bigger vision of getting to Mars. Compared to the drone ship, which is roughly 300 by 150, the usable landing area that this pad has is much bigger than the drone ship. The obvious issue that you have with landing on drone ship is the waves. The water moves, the drone ship moves. Having a completely perfectly still object that never moves is beneficial and does make the job easier. The primary plan is to land on land, but should there be missions that require downrange landing, the drone ship will still be used. Once it lands here, we don't have to ship it from, however many hundreds of nautical miles out at sea back to a port. It's right here within 1,000 feet of the processing area. So that's another area that we get a benefit from landing on land. After the vehicle launches, we get to stage set a couple minutes into flight. From that point, the first stage begins its re-entry, and we do a boost back burn to get the rocket turned around and heading back towards the pad. As the vehicle starts to descend through the atmosphere, we do a re-entry burn to slow the vehicle down. And then lastly, we do a final single-engine landing burn to do a soft touchdown. All of that happens between 6 and 10 minutes after launch, so it's pretty quick from the time we lift off to the time we land. I've always looked at what we're about to do here as one of those things that people will always remember where they were the first time they heard SpaceX landed a rocket. And it's going to happen right there.
It's T-minus 5 minutes here, and I'm right back here now with Tim Urban, from the creator of the website Wait But Why. It's your first rocket launch here at SpaceX.
Yeah, this is weird.
You guys have
to land a very weird job. I'm freaking out a little. I don't know how you guys just do this all the time.
Yeah, very exciting. It's extremely exciting right now. And in fact, it's right at the time right now we're actually about to start retracting that strong back and waiting for the last few minutes. We're about to launch ORBCOMM satellites to low Earth orbit and then hopefully bring that first stage back onto land. Exactly.
Yeah, so we all here at SpaceX kind of know why this is such a big deal for us. What resonates with you and with your readers when you talk about the stage return?
Yeah, so that's one of the things I started to learn as I researched SpaceX. It hit me. There's two totally different things that SpaceX does. So, and I don't think people quite get that. So just to be really clear about it, there's the first thing is what they do to pay the bills. It's what SpaceX does on a day-to-day basis, which they bring things to space for people.
Yeah, satellites or ISS.
They're a space delivery service.
Right. Yeah.
But that's the means to the long-term end for SpaceX. The reason SpaceX started and the long-term mission is to dramatically reduce the cost of space travel for all of aerospace. And this is not just a big deal for SpaceX, but for all of aerospace. And the reason is, if you think about airplanes, if an airplane only worked once, it would cost $1.5 million.
Yeah, so if I'm going to fly from SF to, or LA to New York, either one, and discard the plane every time, it's going to be pretty expensive.
Yeah, you're not flying anymore. You're not flying anymore. And they're cheering, and I don't know why. This is part of it. I don't know.
They're cheering right now because that strong back is retracting, which you can see on the top screen right there on the camera.
Once that happens, that means things are really looking good. We're primed.
We're moving. But anyway, the thing that people have to understand is that reducing the cost of space travel means that we could we could really bring people to Mars. We could colonize Mars, and it's that kind of stuff that's those kind of possibilities that are opened by this. And so what we're seeing today is both things in action. It's delivery of 11 satellites and trying to land the rocket, which would be a huge step in the long-term direction.
Right, and we're about 2 minutes and 45 seconds away from that. That strong back pulling away has been our final moments. What we do there is we press up the rocket right before we're ready to go. It's kind of like, think like a Coke can. So your Coke can, you can step on it if it's full and it's still sealed, and then as soon as you pop it, you can now stomp on it and crush it. It's the same deal we're doing here with the rocket. We press it up, then we retract and let that strong back open.
Everything's looking good right now?
It's looking really good. It's looking really good. And everybody here is super excited. I mean, you normally have watched these things from home, right?
Yeah, like sitting on the couch. Much less stressful there.
Much less stressful, but more awesome here, right?
Much more awesome.
Yeah, of course. Okay, well, it looks like we are approaching the last few minutes of terminal count. So what we're gonna do is we're gonna stop talking to you, and we're gonna let you listen in to the countdown net for the last minute and 59 seconds.
Copy that on wind loads. Sim Team Frank on countdown 1.
LD verify, go for launch.
Loads look good. Loads look good. Box is closed out. Box load stage 2 closed out in 2 minutes. LC, LD, go for launch.
Copy. T-minus 1 minute. BC, verify F9 is in startup.
Falcon 9 is in startup. Flight software has control of the vehicle. Stage 1, Stage 2 pressing for flight.
T-minus 30 seconds. T-minus 20 seconds.
Falcon 9 is configured at flight pressures.
T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We have liftoff of Falcon 9. Falcon 9 is cleared the tower.
Michael Hammersley, materials engineer, and I'm going to talk you through some of what you're seeing and hearing as the vehicle continues to ascend. You can tell that we've had a successful liftoff initially. The Falcon 9 has cleared the towers, and it is rapidly approaching what's called maximum aerodynamic pressure. This is known as max Q. It's when the rocket is pushing hardest against the atmosphere.
Speed 550 meters per second, downrange distance 2.3 kilometers.
For this. You can see the engine plume.
Stage 1 propulsion is nominal.
The engine plume widening as the rocket is increasing in altitude and there's less pressure.
Telemetry power still look healthy. Impact has begun chill.
MVAC chill means that the second stage engine is preparing itself to ignite. Shortly after main engine cutoff, we're going to separate the stages and begin the second stage ignition.
T plus 2 minutes. Speed 1.2 kilometers per second. Downrange distance 11 kilometers.
Main engine cutoff approaching shortly. Returning to land as the second stage powers the ORBCOMM satellites to low Earth orbit.
Stage 1 is on its flip.
The fairings have successfully deployed. You can hear everyone is phenomenally excited here. The Merlin vacuum engine is burning bright as it's moving up to speeds approaching 8 kilometers per second. The first stage will soon begin its series of 3 burns to head back towards Cape Canaveral. First, it will reorient itself. It will reorient itself using cold gas thrusters. It will perform 3 more burns as it approaches landing zone 1.
Stage 1 boost back is starting.
The boost back is the primary burn that will get the vehicle moving more slowly
propulsion is nominal.
and heading back to Cape Canaveral.
New Hampshire acquisition of signal.
Man, that is awesome. We are well on our way to taking ORBCOMM to orbit, and that boost back burn, that's the first step of a really intense process to get that stage 1 back on land, man.
Yeah, like so many things just happened. My heart beat twice. 2 beats since we were on last, first of all. Secondly, there were so many important things. There was first the takeoff, the immediate takeoff, which is just a huge relief. Then there's max Q, and you have the maximum pressure. Past that, huge relief. Then the stage separation, and everyone here went nuts. People here were going crazy. And then the boost back. So everything is so far looking great, right?
So far, so good. Yeah, that boost back burn is going to go on for about 30 seconds, and then it's going to cut off. We're going to flip the stage back around, and as we enter that atmosphere, those grid fins are going to pop out and start the guidance in through the atmosphere.
And so we're about 4 minutes away from when it would touch down, right?
Exactly, okay. Yes, about 4 minutes away.
Everyone's really excited.
There's a lot
here.
of energy.
It's awesome.
A lot of
so
energy.
much energy. So much energy. Yeah, that boost back burn is really important because it reorients us back down to the launch site, back down to landing zone 1, as opposed to normally after the first stage separates from a rocket, after the second stage separates from a rocket, that first stage will continue on a sort of ballistic trajectory and crash into the ocean, but we are coming back to land.
One of the things I think that is another thing that I just not that intuitive is what an orbit is, and so right now the second stage is
going far into orbit.
Right,
Yeah.
it is going faster and faster and higher to try to ping these satellites off into orbit. And what that means is you're not floating in orbit. The gravity is almost the same as it is on Earth. So what's happening is it's almost like the second stage is like a giant throwing the satellites as hard as it can, so that they're going 17,000 miles an hour. So you can basically curve around the Earth. They're falling, but they're going so fast that they're actually curving at the same curvature of the Earth.
Well, yeah, and I know the same thing. A lot of people that I think about think of space as just going up really high and back down, which is a lot of like space tourism kind of things. But what we're trying to do is we're trying to deliver satellites and stuff like that.
They're super
It's
fast,
really fast
sideways.
which is why it's really hard to bring this stage back, because the faster you go, the harder it gets to actually come back as well.
Yes. So, and also, you know, being able to get all of these satellites into that orbit, that's really hard. But then having 11 and getting them to maintain their orbit is also really difficult.
But let's check in actually with John Innsbrucker for another update on how both the second stage burn is going and also how that first stage is looking too.
We're at T plus 7 minutes, 30 seconds. Everything continues to go nominal, as we like to say here at SpaceX. Falcon 9 continues to power its way into orbit. The second stage is building up to 4.7 Gs of acceleration. Now currently we're about 2 minutes away from shutdown of the second stage engine to get into orbit. Engine performance continues to be nominal. I'm looking at the trajectory. We're going right down the middle of the track. That's good news. We're right where we want to be. For the first stage, you heard about the first boost back burn. Coming up in another minute or so, or coming up very shortly, is the entry burn, and then hopefully the landing burn. And you hear the cheering in the background.
The first stage is on its way. Everyone's super excited out here. That burn's going to last about another 30 seconds or so, slowing ourselves down as we get closer and closer to the landing pad.
Yes. Now this stuff is super, super hard. Not only do we have a series of maneuvers that we need to achieve in order to get that rocket back down to the ground, but it's actually a super complicated thing. Like, you did some cool analogies and cool math to figure this out,
I tried to figure out how hard this really is, and so I crunched the numbers with the size of the rocket and the size and how high it's going. What's happening with the first stage is it's like launching a pencil over the Empire State Building, having it reverse, come back down, and land on a shoebox on the ground in a windstorm. That's what's happening.
The critical part.
Yes, and I don't think I could throw a pencil over the Empire State Building and catch them.
It's insane thing to try to do. And the crazy thing is, we're like 30 seconds away from this getting
this
down.
crazy maneuver.
This extremely energetic room is a hush.
Just getting the last burn going in. Landing legs should be deploying in about 10 seconds or so. That is a view from the landing pad.
That is that first stage coming back down to land at Cape Canaveral. History in the making, guys.
Stage 1 is landed. LZ-1, the Falcon is landed. Landing operators moving to procedure 11.100, section 3 on LZ-1 BNet and recovery net.
Repeat, the Falcon has landed.
Landed the first stage of our rocket onto landing zone 1. It's standing up there straight and proud and beautiful. As you can tell, everybody here is going absolutely insane. And rightfully so. This is huge.
Huge first time this has happened. Mood here is just extremely exciting. Tim's so happy you can come out and join this.
Yeah, this is unbelievable. This is the most exciting thing I've ever witnessed.
Yeah,
I've never seen a group of people more excited, like freaked out excited, like the looks and people's eyes here. And I gave someone a jumping hug. It's hard to understand what a big moment this is. Every single space agency in the world is watching this. This is, there's so many quotes of people in space agencies saying, this will never be done. 5 or 6 years ago, people saying, it's not possible to land the first stage. And they did it. You guys did it.
It's a huge
nice going.
And we just got confirmation we have a successful, good orbit for second stage. We're making preparations to deploy the ORBCOMM satellite. So we are on a nominal trajectory for the second stage as well.
I can't hear him.
Point him out there.
This is such incredibly an exciting thing. It's important to remember that our primary mission is, in fact, to get those 11 ORBCOMM satellites into orbit. There are going to be a series of 6 separation events, and in a moment, you will see the first 2 of the 11 ORBCOMM Generation 2 satellites separating from the second stage of the Falcon 9 rocket. We have cameras for at least some of those deployments, and those will be coming along shortly. as the mission continues to progress nominally. A couple quick facts about the ORBCOMM satellites. There are 11 of them. There's also a 12th mass simulator, and that's there to just provide balance. Each satellite weighs about 172 kilograms, and it's for a total mass of just over 2,000 kilograms. For reference, that's about the size of a fully grown adult lion. Each satellite, when stowed, is about 1 meter by 1 meter by half a meter tall. So about yay, and straight down. It's about the size of one of the small refrigerators. But that doesn't mean it's nowhere near that simple. Fully deployed, the satellite actually extends out its arms 13 meters, about the size of a telephone pole. Now, the 11 satellites are mated on 3 tiers. There are 4 farthest away, then 3, and then another 4 fairly close to the Merlin vacuum engine. And now the way that we're going to begin deploying them is with the 4 satellites on top, then the 4 satellites in the bottom, and then the 3 satellites in the middle.
Back to first spacecraft.
And
payload spacecraft
we
1 and 2
have
have been deployed.
Visual confirmation of satellite deployment. Mission is continuing to progress nominally. We have 5 more satellite separation events. Now, the reason that we're staggering these deployments is in order to allow the satellites to have some spacing, to give them their proper location within the constellation that's going to provide that continuous global coverage that Lauren was speaking about earlier. They have a parking orbit of about between 620 and 660 kilometers in altitude. And we're waiting for confirmation of the next few sets of deployments.
Spacecraft 3 and 4 have been deployed.
You just saw the next 2 satellites deploy. Mission is continuing nominally. You'll notice that you can only see 1 satellite come off the actual payload fairing, or fairing adapter, forgive me. That's in order to keep the satellite and second stage moving in a straight path.
The 3rd satellite deployment, as you can hear, everyone here is just extremely, extremely excited that we both have a first stage that is sitting on ground, and also we are taking care of the nominal primary mission here. It's all about delivering those satellites to orbit as well. The secondary, the sugar on top or whatever.
The very
Cherry on
delicious,
top was the first
delicious
stage
cherry
thing.
on
Well,
top.
because the worst thing that could happen is after this incredible moment, if something goes wrong here, it really would kill the bus. So, we really, want to get this right now just to orient me and everyone up. So,
CE,
3 have been deployed, correct? Correct.
Yes.
Out of
Well,
5.
3 deployment sequences, 2 satellites per deployment. So 6 have been deployed, which is just over half of them.
And now there's 2 more deployments.
3 more deployments.
3 more deployments?
Yes.
Okay. So for 11 total.
Correct.
And you're only seeing about 1 go off at a time because that's given our camera angle. The other has half of that tailored cabin fitting. You can see there's another satellite as well.
Great.
Another successful deployment. We have confirmation that that is good. And just remember, that is a live view from space. That is the blackness of space. We are 620 kilometers in space right now.
What I think is cool, it looks like it's just sitting there calmly and these things are coming out and everything's going slowly when the fact is, these things are going 17,000 miles an hour. Right. And I kind of figured out once that if you're on the beach and something was going this fast out into the ocean, it would go over the horizon and out of sight in a half a second. That's how fast these are going.
It's insane. And there's
it
the
looks like
4th
we just got
deployment. It's
deployment
another
of the
successful
next one.
deployment. There's one more. And we're waiting for just the final deployment of the constellation here. Should be about another 20 seconds or so. We'll be seeing that last satellite be separated.
This will be the 11th satellite, and that will complete this mission. After we deploy this final satellite, we will then deorbit the second stage. And we have successful deployment of the 11th and final satellite on the ORBCOMM mission.
Is there another satellite? That's it.
All right. And with the successful deployment of all 11 of these satellites, it is time for us to sign off today. This has been a wildly successful return to flight for SpaceX, a wonderful first flight of our Falcon 9 upgrade, and of course, the thing that got everybody really going crazy here, we made history today by landing the first stage of our rocket back on land in Cape Canaveral, Florida.
Yep, thanks ORBCOMM for today's mission, and special thanks to the Air Force 45th Space Wing for all their range support, as well as the FAA for licensing our mission. Make sure you stay connected with us on SpaceX, on Facebook, Instagram, and Twitter. And also, if you want to join us up here,
SpaceX.com/careers. Come join the family.
and definitely thank you as well, Tim, for joining us too today.
Yes.
Thank you guys. No one noticed I wasn't supposed to be here.
And to all of you for watching, thank you for joining us here today and being a part of this historic day for SpaceX.
All right, thank you again for hanging out with us today. And remember, the goal is Mars because nobody wants to go back to Jakku.